During the last few videos, I explained in detail IAM roles for service accounts. I had to deploy the Pod Identity Webhook manually in the default namespace. This is not really the greatest way to do this because the default namespace should not be used to deploy control plane components. This is because you might need to implement a good RBAC strategy to keep the critical components out of reach of the normal users, the day-to-day users, and also just to keep the default namespace clear. So in this video, I'm going to briefly go through how to deploy the Pod Identity Webhook in a dedicated namespace. At a glance, this should not be that much of a hard problem. You should be able to just change the namespace values in some of these resources and then deploy them. But I thought this might be a good opportunity for me to discuss the inner Kubernetes design of the webhook, for the total of 2 other people out of the whole world who would be interested. So let's dive into the details. Right, so the Pod Identity Webhook is essentially another workload that runs as a deployment. This is a deployment that is fronted by or reverse proxied by a Kubernetes service. So if you know about Kubernetes, you know what a Kubernetes service does. And the deployment also has a service account attached to it, which has cluster role bindings, and all the permissions, the RBAC stuff that is needed for the webhook workload to actually function. Since this is a service, the TLS configuration for this service is managed by another external component called the Cert Manager. The Cert Manager is not an AWS released component. It's a separate project that is, I think, under the CNCF umbrella, but it's basically kind of an operator that introduces a couple of custom resource definitions, CRDs. The 2 most important CRDs for us is a cluster issuer, which defines how certificates should be issued, and a certificate resource. So with these CRDs, we can request new certificates as Kubernetes resources. And when this certificate is signed, Cert Manager generates the signed certificate as a Kubernetes secret. Basically, any connection that connects to the webhook server will verify the authenticity of the server using this signed certificate. And after all of this, the service gets registered in the Kubernetes API server as a mutating webhook configuration, so that anytime a pod is created in the Kubernetes API server, the API server will call this service through the mutating webhook configuration. If a certain pod needs to skip this webhook call, an annotation called skip pod identity webhook can be added to the pod definition itself. But I reckon that's a condition that never gets evaluated to true because most of the time you need your pods to go through all of this validating and mutating webhooks. So that's basically the Kubernetes architecture of the Pod Identity Webhook. Let's go to the terminal, change some values, and deploy the Pod Identity Webhook in a dedicated namespace. So I have a new kind cluster, Kubernetes in Docker cluster. I created a new cluster for this deployment, so I don't have any of the old deployments that I did in those previous videos. So just to check, I only have a couple of namespaces here, all of those default namespaces that you get with a kind cluster. Let's go ahead and create a new namespace for our Pod Identity Webhook. The namespace is now created. We'll need to go back to the repository and change some values. So as a start, let's change the obvious places, which is basically metadata.namespace entry for all of the resources. Okay, so all the metadata namespace entries have been changed, and also a couple of entries that were in roles and role bindings were also changed. This should technically deploy all the resources in the correct namespace, but there are some other changes that we need to do to get the Pod Identity Webhook actually working with that new namespace. So one of the easiest places to change is the namespace that is getting passed into the deployment, the actual deployment, as command line arguments to the Pod Identity Webhook. Now this namespace being passed is not necessarily useful in the scenario that we are using the webhook for, because the namespace is usually used when Pod Identity Webhook is used in an EKS Pod Identity scenario. In our case, it's not actually watching something like a config map, so this change would not necessarily be needed, but let's just go ahead and change it anyway. The next place that I should change is going to be the certificate that is created to generate a signed certificate for the webhook server. So the entries that I have to change here are about the common name and the subject alternative names for the certificate. If you don't know what these are for a TLS certificate in a DNS context, there are a lot of resources online that you can search for to understand what those are. But to put it briefly, these are the DNS names that the service will get called by the external callers. So for an example, when the mutating webhook calls this service, it will either use the fully qualified domain name of the Kubernetes service or just the service name. But if it uses the fully qualified name, then that name includes the namespace that the service is deployed in. So we are going to have to change those entries too, otherwise the TLS verification will fail with this call. The next entry that I should change is going to be in the mutating webhook configuration. So that is the place where we actually configure the API server to call this webhook when a pod creation request is submitted. The first place that I'm going to change is going to be the namespace of the service that the API should call. So that's an easy one. The next entry here is an annotation in the mutating webhook configuration, but that is also about the service that is getting called by this caller. Depending on the value of this annotation, Cert Manager will include the certificate bundle to this webhook configuration so that the caller would be able to trust the certificate that is provided by the service. The alternative here is that you'd specify that certificate bundle as the CA bundle under this service configuration. So you can have Cert Manager do that on behalf of you. So the detail here is that that secret is going to be in the new namespace that we just created. Alright, so the changes that I needed to do are done to these artifacts. This also includes the changes that should be done to update the image and also to update the token audience. If you don't remember what these are, please go back to the previous videos. I have explained all of this in detail. Now let me deploy these artifacts in the new namespace and let's create a new pod and see if that pod gets mutated. So if it does, then we have successfully deployed the pod identity agent in a dedicated namespace. Okay, I have deployed the pod identity webhook in a dedicated namespace called the pod identity webhook, obviously, and it is running and it's listening on the correct port. So let me just create a test pod. Okay, so I've deployed a test pod in the default namespace, and I used the same pod definition that I used in the previous video. What I did extra was to create a service account and annotate that service account with the same annotation that I used also in the previous video, and this time instead of a proper role ARN, I used this value called dummy value. And all the pod identity webhook did was to actually get that value and inject those two environment variables and a service account projected token volume into the pod definition. I'm not going to do the full demo for IRSA here because that's not necessarily needed for the scope of this video, but I think this would be enough detail for you to go ahead and deploy the pod identity webhook in a production scenario. Now that I'm here, let me also cover some of the other details that I could not cover in those previous videos. Now, the annotation prefix that I used when annotating the service account was EKS Amazon AWS.com, and I said in the last video that if for some reason this doesn't work for you, you can also change that value. And how you change that value is by changing this flag in the pod identity webhook called annotation prefix. So for an example, this could be, and all you have to do is to redeploy the pod identity webhook and change the annotation prefix to match this value. Same goes for the token path, where the projected token volume for the service account gets mounted. That path has a directory called eks.amazon.aws.com. So if that doesn't work for you, you can also change this value by using another flag called the token mount path. All you have to do is to add this to deployment base basically as another flag, and you can specify a different value if you don't like eks.amazon.aws.com for some reason. Okay, so that's probably enough detail for IRSA at this moment. There's probably some more details that I've left out, but let me just finish this topic here. And in the next video, I'll discuss how to deploy third-party solutions to tackle the same problem as we did with IRSA, how to authenticate into AWS with Kubernetes workloads. I hope this was useful in some way to someone around the world. If it was useful, then like the video, also subscribe if you haven't already. But that's it for me. Thank you so much for watching. I'll see you in the next video.